So I've got a question here. Coca-Cola have decided to shape their cans into a perfect cylinder. This cylinder has height h, radius r. The cylinder must have a volume of 330 milliliters. What combination of r and h will minimize the amount of material used? Well, at first glance, this looks like it has nothing to do with differentiation, but it does. So first of all, what I'm going to do is I'm going to say, well, our volume must equal 330 milliliters. We could alternately say, well, how can I represent this in R and H? Well, it's a prism, so times the area of the top surface by the height. So pi r squared, which is our top surface, multiplied by our height. So how many different of these top surfaces do we have? What I can then do is I can then equal them. So 330 equals pi r squared times h. This will be useful in a minute. I want to look at this part, so the amount of material used. They want to minimize the amount of material used. That's like our surface area. So I can say, well, our surface area, I'm going to call it A, is equal to 2 pi r squared, so 2 of the top surface, plus the outer surface, which is going to just be a rectangle. If you were to imagine a wrapper, you unraveled a wrapper, it's just going to be a rectangle. And it's going to be 2r pi, that's our circumference, multiplied by h, which is going to give us that outside. I can call this like equation 2, and I can get rid of one variable. Well, I can divide by pi r squared, so I get 330 divided by pi r squared equals h. I can then input that value, so I get a equals 2 pi r squared plus 2r pi multiplied by 330 divided by pi r squared. Now, I hope you can see the pi will cancel, one of the r's will cancel, and I should be left with 660 divided by r. So I get 2 pi r squared plus 660 divided by r, but that's the same as just r to the minus 1. Now, this is just a function. What value of r is this function minimized? Well, I can find dAdr, and I can find a minimum point. So I'm going to get 4 pi r minus 660 r to the minus 2. I can equal this to 0, so 0 equals 4 pi r minus 660 r squared, or r to the minus 2. I can then times through by r squared. So I get 4 pi r cubed minus 660. I can add 660 to both sides and divide by 4 pi, and finally cube root. And this here is our value of r for when the surface area will be minimized. Now, what we can actually do from here is we can, first of all, we can put this back in. That will allow us to find h. We can also then put this value of r into our a, and this will give us our minimum surface area. I'm not going to put that in. I think you would be able to put in just a value, but do be careful. The whole of this inside is cube rooted. Thanks for watching.